Want to get your installation right the first time? It all comes down to the plan. In the next few minutes, we'll show you exactly how to plan your layout like a pro. Let's get started. The blue line will represent the data path, and the red lines will represent power injection. Our first example is a standard bungalow. For this layout, the ideal placement for the controller is in a central location, such as near the front entryway, which often has a switched soffit outlet. From this central controller, the data line runs as a single, continuous path. It extends left, follows the first peak, jumps across to the garage, follows the garage roofline and second peak, and then returns. This entire layout is one daisy chain for the data. Because the total run length must be managed, power injection is required. We will run 3 separate power lines from the supply, attaching them with T-connectors at strategic points, one on the left peak, one on the garage peak, and one near the end of the garage run. Let's review this center controller layout. The longest run from the controller is only 45 to 50 feet. It requires 0 Y connectors and only 3 T connectors. This is the most efficient and stable design. Now, let's take that same house, but assume the only available power source is on the far end of the garage. This end-of-run layout requires a different strategy. The data line starts at the controller. We immediately use a Y adapter to split the signal. One path goes up to trace the roofline, while the other path runs along the lower soffit. For power injection in this scenario, we still run our lines from the controller. One line goes to the upper peaks. For the long bottom run, we use a technique called leapfrogging. We run one power line to the middle of the garage, and then tap off that same line to extend power further down, ensuring the entire run stays above 10 volts. To summarize this layout, our longest run is now 60 to 70 feet. It required 1 Y connector and 3 T connectors. While this is a perfectly stable installation, note how placing the controller at the end, rather than the center, increases complexity and the length of our wire runs. Let's move to a more advanced 2-story home. Again, we will assume a central power location, which we've placed on the left side, between the 2 floors. This central placement is key. With a central controller, we can map the data path as one single, continuous run. We'll trace the lower roof line, jump up to the garage, trace the garage peak, jump to the main upper roof line, trace those peaks, and then finally jump across to the last remaining section. As you can see, even on a complex roof, this entire layout can be accomplished with 0 Y adapters, just a single, clean data line. Now, for power. From our central supply, we run multiple power lines. One line services the entire lower roof section, leapfrogging once to reach the far end. A second line runs up to service the entire upper roof, also leapfrogging to distribute power evenly. This center-fed design is the gold standard for maintaining brightness and stability across the whole project. The result of this central layout is a longest run of only 40 to 50 feet. It requires 0 Y connectors and 5 T connectors to cover the entire home. This is an optimal installation. An alternative, and often cleaner, method for the same house involves Y adapters. From the central controller, we immediately split the data. One line runs left to cover the lower section. The second line runs right and up, where it feeds into another Y adapter to split the signal again for the multiple upper peaks. This method greatly reduces the need for long, visible data jump cables between roof sections and keeps the lighting patterns flowing logically. The power injection for this layout is similar to the previous example, except using one less T connector, with lines branching up and down from the central supply. In this case, our longest run is still 40 to 50 feet. The design required 2 Y connectors and 4 T connectors. This demonstrates how Y adapters can simplify your data path without compromising power.